This is the plenary meeting of the Persistent Identifier Interest Group. Our group is self-styled as the cross-pollination group, and you'll see I've got that in my little background there with the bees on the peonies. We are the self-styled cross-pollination group for persistent identifiers at Research Data Alliance and beyond. We're trying to bring together a place where you can keep up to date with all the different developments in persistent identifier systems, services, and applications, as well as doing a bit of cross-pollination and potentially spawning off collaborative type, at least ideas, if not activities. We've got a really nice set of speakers today. As you'll see, we've got them in 3 different clumps, updates on PID services, then some updates on PID usages and reflections, and then a couple of presentations about the broader ecosystems of persistent identifiers. Lightning talks, so they're just meant to give you a quick update and alert you to what's happening, and you can ask them further questions. After these lightning talks, we will have some broader discussion, and you can ask further questions of the speakers at that stage and get more information. We will start, I think. Our first speaker is Maria Gould, who will be speaking to us about RAW.
Adrian, do you mind driving with the slides?
Of course.
I don't know whose that is.
That's not you?
No.
I had put that one in early just to put everybody in context.
This is me. Great. All right. Hello, everyone. I'm Maria Gould. I work on identifier services at California Digital Library, and as part of that role, I am the project lead for ROAR, which, for those who don't know, ROAR is an open registry of identifiers and metadata for research organization affiliations. So I'm not really giving too much of a ROAR specific update right now. I've provided some at previous RDA sessions and other spaces, but what I really want to focus on today is that ROAR is really not the point. And I want to really focus on this theme of joining up the world and how ROAR can be used and is being used to connect to other PIDs and be leveraged in scholarly infrastructure. So next slide. So the bottom line and really the thing to know about ROAR is that the motivation in developing ROAR was that we depend heavily on identifiers to discover and track research. But for a long time, there's been this missing piece. We've had DOIs for research outputs and ORCIDs for research for researchers, but haven't really been able to fill this gap and completing the circle of people, places, and things, so to speak. And that's long been a kind of missing piece or sore spot in PID infrastructure. So next slide. So ROAR was launched essentially in 2019 as the first and only registry of identifiers that is truly open. It is specifically focused on identifying affiliations, that is driven by community needs and is supported in open and community-driven infrastructure like Crossref and DataCite. So it's up and running. There are a bunch of organizations in the registry right now. We have open tools for working with the ROAR data. So it's here and it's ready. Next slide. And so now that ROAR IDs are starting to be implemented in research infrastructure, we're really beginning to see the promise and potential of having this open identifier for affiliations. So this really begins with affiliations being captured, such as this example in Dryad's submission system for dataset publishing, where the affiliation field in Dryad's system is connected to the ROAR API. So researcher affiliations are captured in a standard way. Next slide. And then the next piece of this is making sure that ROR IDs are included in DOI metadata. So this is already supported in the DataCite schema, and you can see in the XML here how the ROR ID is showing up in the metadata that Dryad is sending to DataCite when it registers DOIs. Next slide. And then lastly, this really unlocks the potential to link up all the identifiers, which is really the theme of today's session. So showing here this the new discovery service, DataCite Commons, that has recently been launched, that's bringing together DOIs and ORCID and funder identifiers along with ROR to really be able to visualize the true nature of research. And there's so much more potential going beyond this that we're going to hear about later in the session, such as how to bring in DMPs, how to bring in grant identifiers, and really how to join up the world. So next slide. So the bottom line is that ROR is here. ROR is all about joining up the world with identifiers, and we're excited to do this together. And I'm happy to answer questions during the Q&A.
Great. Thanks very much, Maria. In the spirit of the lightning talks, we'll go straight on to Jens Klump, I believe, from IGSN. Jens, do you want me to run the slides, or would you like to? Jens? And or Anita?
You can go ahead and do my slides if you want. I think yeah, it's a while. You've changed the order, so they're kind of farther down.
Whoa.
I can't speak that fast, Adrian. You're going to have to go slower through my slides.
Yeah, I'm in the. Okay, there it is. Yep, perfect. All right, thank you. So I'll talk to you today about RIDs. These are PIDs. Next slide, please. And we do exist. Can you keep clicking until you get to the end? I think it's just 2 more clicks. So these are for materials, and some of you have seen this slide before. This is my favorite reproducibility slide. RIDs are for the materials used in a paper. They make methods much more reproducible, and they are enforced by journals such as Nature, Science, and Cell. This is my favorite picture of a reproducible scientific recipe. And you know, if any of you cook, you know that the first thing to do is to figure out, you know, what stuff's in the cabinet and what you're going to have to go out and buy. So if you go to the next slide. The problem is that when you find these kind of things, like here I've highlighted NOD PK skid IL-2, this is a mouse, and next slide or click. The problem with these kind of things is that unfortunately, we really do fail because the way that authors talk about their reagents and their mice and their cell lines often leads to actually a lot more confusion about what they're actually using. Next slide. And in fact, this is very, very common. About 50% of the time, you cannot track down what the authors have used in a scientific recipe. Next slide. The problem, though, is that the author actually usually knows exactly what they used. And so while the author is there, while that postdoc is still in the lab, they can actually very quickly pull the information out from their lab notebooks and what have you. So the problem isn't that they don't know what they're using, that it's a bad study, it's just a reporting problem. Next slide. And so this is an example of a more recent paper. This one is on SARS-CoV. And what it demonstrates there is that the solution from one of the journal publishing groups that, that we've worked with for now many years. And this is the STAR methods table. And what the STAR methods table asks every author to do, this is required in every Cell Press journal article, is just list their reagents or resources and the identifiers for those. And many of those are actually linked. So that link goes right to more information about that entity. Next slide. Okay, so what do they cover? What do these RIDs cover and how? They actually cover things like plasmids. So for those of you not in biology, these are snippets of DNA often wrapped up in a virus. And there's 85,000 of those. There is, upwards of 500,000 different kinds of organisms you can buy. There are lots and lots of cell lines, antibodies, and tools is a funky one. But there are things like statistical tools that people also use. And those are covered under that tools component. Each RID type has one or more authorities. So an RID is kind of a meta identifier on top of a bunch of other identifiers that are given out by the authoritative databases that hold or in many cases sell those particular resources like those mice or what have you. Next slide. This is just a quick workflow. The journal usually sends people to the RID website. The author goes into the search box. They type in their favorite search word to try and find all the things that they used. And there is a cite this text that they then copy and paste into their manuscript. Once the paper is published, now anybody can search Google Scholar or PubMed Central or whatever just by using the identifier, and that tells you how many papers actually have used that particular item. Okay, next slide. And there's a lot of these now. There's about 25,000 papers that we've verified. If you ask Google Scholar, there's more with RIDs. In 2020, though, this only constitutes between 3 and 40% of the total literature where we think that the RIDs should be used. So we have a long ways to go. Next slide. So I'm going to call out to everybody here, instead of thanking all of my wonderful colleagues who certainly deserve a lot of thanks. We are going to just call on everybody to review their papers largely for methods if they review, and of course to put RIDs into your next paper so that your paper can also become data. And as a quick note, you can actually, so we are also trying to hook up with both ROAR and ORCID. And so Maria, thank you so much for that, for all of those wonderful tools, which we are exploring currently to make sure that our identifiers are also compliant with the community. Thank you.
Thank you, Anita. Now let me just get this a little bit more elegant than last time. Now we don't seem to have Jens on the call right now. You're muted, Natasha. I can see you speaking.
Sorry, he's on the way. He's
okay.
On the way.
You're okay to do the RAID one now, Natasha? You want me to?
Yes, would you mind doing the slides because my bandwidth is very bad.
No worries.
Okay, thank you. So I'm Natasha from the ARDC, and I'm going to talk to you about RAID, the Research Activity Identifier. So what do you think of when you hear the word RAID? Do you think about pirates raiding ships in the Caribbean? Next slide. Do you think about raiding the refrigerator in the middle of the night? Next slide. Do you think about a can of Raid that you use to spray on little creepy crawly things? And that's what we do in Australia. Next slide. Well, whatever you think of, RAID is a verb and it means doing something. Next slide. So in the context of research, research activity identifier refers to a doing thing, so a project or an activity. Next slide. So RAID puts projects at the center of research. So a research project has a lot of activities that happen through it and a lot of entities that interact with it. So institutions are associated with a research project. There's a project team, there's data collected, publications done, there's tools and services that the projects interact with, and sometimes, not always, there is funding for that project as well. Next slide. So the RAID at its essence is a handle. with an envelope. So if you think about the front of the envelope, project here, for example, is Cure Cancer, and the RAID is a handle, and then it has an envelope. So next slide. So if we open the envelope, inside that, we have a lot of PIDs and metadata. So we have the ORCID identifiers for the research team. We have the DOIs for the data and publications. We have the RAW for institutions. We have the DOIs for the grants. And we have other identifiers collected for tools and services. And you can also have other project RAIDs associated with this in this envelope as well. Next slide. So how does RAID work and why is it useful? Well, it collects those outputs and activities with a research project in the one place. It uses a machine-to-machine REST API that enables that joined up project-centered view of research, which is very useful for institutions and tool or service providers to be able to track who's using that infrastructure of theirs. And because RAID is an envelope that groups identifiers and metadata, it has potential for other uses. So the openness profile is looking at it as a way of grouping open research outputs. Next slide. So its current status is that the ISO certification process is underway, and we expect that to complete in May 2021. Next slide. And it also has an ORCID integration, so RAIDs can appear on people's ORCID profile, and that's in production now as a machine-to-machine thing. Next slide. So in terms of the early adopters program, we have a number of organisations in production and a further with keys to production, over 5,000 RAIDs minted, some interest from the openness profile, the US Department of Energy. The RAID envelope has a lot of identifiers already integrated with it, and we're looking at other use cases and to develop that as requests come in. Next slide. And in terms of the governance, it comes under the ARDC's PID services program, which has been in over 10 years of operation, if you include the Australian National Data Service before that, which ARDC includes ANZ now. And our staff sit on a range of international PID boards and initiatives. And I mention that to indicate that we're not a fly-by-night organisation, that we have a commitment to making a success of RAID. Next slide. So finally, our roadmap is to complete the ISO certification and to grow our early adopters program. So it's a chance to come in with ideas and use cases at this point in time. And we want to further develop governance and technical architecture to underpin the sustainability of RAID. Next slide. Last one, if you'd like to, if you're interested in RAID, just drop us a line, contact@ardc.edu.au, and please engage with us to help us understand how RAID could be helpful for you. And that's it. Thanks, Adrienne.
Thank you, Natasha. Wow, we've really had very, very good timing today. Is Jen's with us yet?
Yeah, I'm online.
Okay, Jens. We have your slides here. Would you like me to walk through them, or would you like to control it?
Yeah, I'll if you could forward them for me, yes. Okay. We're just there.
What? Did I just go past them?
Yeah, you went past. You were right there.
I was right there. Okay. So.
Yep.
There. Okay, next slide. I wanted to tell you just in a few words about the IGSN global sample number, which is a persistent identifier for physical objects. Next slide, please. And so in a nutshell, the famous elevator pitch, you know how difficult it is to track samples across institutions and system boundaries and unambiguously link them with data and literature. Well, what we do is provide a persistent identifier system for physical samples that provides a globally unique resolvable identifier that is compatible with other PID systems. In fact, IGSN is already used by major research centers and government geological surveys, and it is endorsed by scientific publishers. Next slide. In a few more words, but still short, we all know that samples are the heart of research. We see them in many different forms, not only in the natural sciences, but also in medical research, in cultural research, and many other fields. Next slide. And what IGSN is that it is a persistent, globally unique, and web-resolvable identifier for physical samples and specimens. And it is domain agnostic, and the samples can be materials from anywhere. In the current system, we already have samples collected by spacecraft, and so they can be from anywhere in the solar system, and maybe they're coming from outside of the solar system, so they can be any material from anywhere in the universe. Next slide. The challenge so far has been that the naming of samples has been either ad hoc by the collectors or systematic within one institution. But when it comes to making these names work across boundaries, then it becomes challenging. And this slide gives you a brief illustration where on the left-hand side, you have the same sample that has been reanalyzed many times. It's a piece of basalt from one of the mid-ocean ridges. And it has all sorts of names in the literature where we assume it's the same thing. On the right-hand side, it's many different things with all the same name. All of them have the name M1. So clearly we have a problem here if we have only locally unique names, and that makes it difficult to bring things together. Next slide. So what we can do with using PID in this case is that we, in this example, have a specimen which is identified by an IGSN, and you can associate an ORCID with it to denote who did what with the sample. The metadata can come in a machine-readable form. This piece has had some measurements done on them. In this case, some reflectance spectra measured on them. This spectrum is published through the CSIRO data access portal. The measurements are identified by a DOI, and people involved with it are identified by ORCID. And then this spectrum was interpreted in a publication, which is identified by a DOI, which has people involved, identified by ORCID. All of this has machine-readable metadata. Next slide. But then we have this aspect of linking things across institutions, but there's also a very practical aspect that we use is using it as a tracking sample. We tested this in a field campaign in the Nullarbor Desert a while ago. Here we pre-printed labels with IGSNs on them, encoded in a QR code, and using an app, the famous electronic field notebook app, to scan the QR codes and automatically populate the metadata, we could show that we could streamline the sampling process and improve the efficiency of sample handling by 100% by, among other things, using IGSN as a tracking number for our samples that we took in the field and then carried them through the lab process and everything. So next slide. Thank you very much for a few minutes on IGSN as a persistent identifier for physical samples. Thank you.
Great, thank you very much, Jens. So, slight shift here now from the updates from our different services to, again, services. We're talking about different DOI persistent identifier applications, but the slightly more focus on the usage. So we'll hear from Maria now about applying persistent identifiers and data management plans. Maria, have you got slides here? Did you want me to do that?
Probably faster if I drive, because I'm going through them kind of fast. So you have to, if you unshare, then I will share. Okay. Oops. Alrighty, so I work with the other Maria G, at the California Digital Library. We both work in the UC3 department. I'm going to talk a little bit about machine actionable data management plans and some work we have done all around sort of the new modernized network DMP, all using identifiers to connect and make a more networked research activity. So machine actionable data management plans, really the key to know about that, they're just working to transfer what is a very sort of static 2-page PDF document into a more interoperable format that allows data and information about research to be communicated across stakeholders. So we have a NSF grant, an eager grant. We've been working on building the infrastructure for this for a number of years now. We're utilizing the DOI infrastructure, generating IDs for DMPs. I'll talk about that a little bit. And we're building on a lot of work that was done out of RDA, particularly in the RDA Common Standards metadata schema for DMPs and the active DMPs interest group. So recently, well, not that recently, May of 2019, NSF came out with a Dear Colleague letter about effective practices for data. And this was really important in this space for 2 reasons. First, it encouraged practices for researchers to include the use of persistent identifiers for data and to use machine readable data management plans. So out of that announcement by NSF, we were given another NSF grant with some other large professional organizations, ARL, AAU, and APLU in the US. We gathered 40 experts in the field for 1.5 days of in-person meetings, which in retrospect is really lovely and I miss. But that meeting really came out with a lot of ideas for how stakeholders could implement some of these recommendations by NSF. And those really focus around how can they incorporate persistent identifiers and machine actionable DMPs into their work and their specific communities. So I've got the short link there. It's a short report. It's only about 12 pages. It's focused around actionable items. So encourage folks to take a look and it might be useful. So a lot of the work we're doing right now is really about modeling the connections made possible through machine actionable DMPs via the PID graph. And the reason we think identifiers for DMPs, specifically PIDs for DMPs, are important for 2 reasons. They create an unbreakable link between a data plan and the project outputs. And also using that infrastructure allows us to access data sites supporting services and supporting infrastructure for things like event data that'll allow us to check for connections using the PID graph. So we're working a lot with DataCite on this work. They are partners on that NSF grant that I mentioned. So we're working with them in a few ways. The first is kind of big news for DMP folks is that in their upcoming metadata schema update is going to include support for DMPs, maybe retitled output management plans, TBD, something along the lines. So that's kind of big in this space. The other thing we're working on them with is to create visualizations of the key connections between DMPs and project outputs utilizing the PID graph. And we've come up with some neat Jupyter notebooks so folks can go in and play around with that. We hope to be demonstrating that at PIDapalooza. So hopefully we'll see you there in January of 2021. And we'll also be releasing best practices for metadata corresponding to the new DataCite schema changes. So this is one of those visualizations. We're still working on it, so it's not in final format here, but the purple in the middle is the DMP. So you can see all of the data sets coming off of it. This one only had one, but they had many publications, so that sometimes is switched depending on the project. All of the people associated, all the organizations and funders, and these all are actual identifiers behind them, so linking them into that knowledge graph. So like I said, a lot of our work is really focused around building the infrastructure necessary for these new machine actionable data management plans. We're doing that in partnership with our colleagues at DCC. So we run the DMP roadmap, which is that open source code base that underlines the DMP tool, DMP Online, and several other DMP tools. So we've implemented a few features recently that support this work. primarily around identifiers. We're definitely going to be adding RRIDs soon, but we've already added RORs, funder registry, ORCID, and that DMP ID. We also have a new API that's compliant with that RDA common standard metadata schema. So the other big thing we're working on is pilot projects to kind of test out these assumptions in real life settings. So the Fair Island project is our big one in this space. We have just hired someone to come in and help that, Erin Robinson from ESIP. So I'm really, really happy she's going to be helping move that along. But really the project is to examine the impact of kind of optimal research, data management policies, and requirements at a working kind of real life field station. So we hope to sort of demonstrate the power of these two things, being optimal data policies and the technical infrastructure. So expect to hear more as we ramp up work now that we have Erin on board with that. Just a lot of partners involved with that Fair Island project. Notably, the UC system is heavily involved with that. We're working with the UC Natural Reserve System, which facilitates access to all of the UC run field stations, which I think is totaling between 60 and 70, so it's big. And the Tetiaroa Society is runs a field station in French Polynesia. It is a beautiful atoll, and that's kind of where we're starting this project as the first kind of field station that we're launching it in. So we'll share the slide deck, but this is just where you can learn more about our work. And anybody who has any questions, wants to talk about it, I'm always happy to hear from people and chat more about it. That is it for me.
Thank you, Maria. Really nice. Our next talk is from Moraine and Roberto. Would you like me to run your slides? Would you like to run them yourselves?
I would prefer you to run the slides, if it's possible, please.
Possible, yeah. Now that I've caught my breath, I think we're up to, that's the slide, that's yours.
Yes, that's it. Thank you very much. So hi everybody, my name is Moran Green-Peter and I'm a research software engineer and the metadata specialist at the Software Heritage Archive. Today I will present to you the intrinsic identifiers against the extrinsic identifiers. Now, we don't want that to be against or versus, but really we want it to be as an addition to what extrinsic identifiers can do. So I will show you a little bit what do we mean when we say intrinsic identifiers, and specifically for software source code identification with the SWHID identifier, which is the Software Heritage Identifier. Next slide. So when you look at those two options, extrinsic and intrinsic identifier, when you look at extrinsic identifiers, almost all the systems that we know now are extrinsic systems that are where you use a register to keep the correspondence between the identifier and the designated object. So for this, we have some examples that are not in the digital era, but are real life examples, like a passport number, which can have a person with multiple nationalities can have different passports with different passport numbers, and these are kept in a system and a national system. And in the digital era, and some of the identifiers that we saw today are here, extrinsic identifiers like DOIs, arcs, handles. And intrinsic identifiers are really intimately bound to the designated object. And this is not something new. You can find it in other places, like chemical notation with the nomenclature and the musical notation. So in the digital era, it's more about cryptographic signatures, commit hashes, and the SWHID. Next slide, please. The software source code identification working group has done a very nice output presenting those differences when it comes to software identification. It captures the current state of the art of practices of software identification, mapping and clarifying the uses of different identifiers, including both extrinsic and intrinsic identifiers. So here we see that there are some examples for the extrinsic identifiers with the error IDs, Wikidata, DOIs, and some registries like SWMath and ASCL. Next, please. But the intrinsic system of identifiers for software is not something new. Already in the 80s, Ralph Merkle has come up with this idea, digital signature based on a conventional encryption function, which can not only identify one single object, but a complete tree, the Merkle tree. It is the basis for blockchain and distributed file systems. So here you have kind of an historical timeline of from centralized local VCS, centralized version control system into distributed version control system, where the most popular one is Git. And as of 2020, there are more than 40 million developers and more than 140 million repositories that are developed. And with these systems and objects in those systems are identified with intrinsic identifiers. Next, please. And so at the end, we come to the SWHID. The SWHID is the software heritage identifier, which identifies an archived object. Here you can see the syntax of this identifier, and you see that it identifies the object type and uses a hash that is computed from the object itself. So if you have this same object on your machine, you can compute the same identifier. You don't need a registry to give that to you. And this is good for many reasons, because you can verify it and you don't need the authority to tell you that that's the identifier. Next. And on this core identifier, you can use contextual parameters that will give you more about where did you find this object and what it came from. Next. So today we won't try it, even though it's let's try it. You can, if you have the presentation, you can click on the link and you'll get directly to this identifier that's here, which is a master ignition routine from the Apollo 11 repository. Next. This identifier is included in the 2.2 SPDX and registered in IANA, and is also Wikidata property. Next. So what I'm here to say, use SWHID intrinsic identifiers when you can and identify publicly available software source code. And that's not enough for many use cases, as you would see in the software identification output, but it's a good way to reference archived objects. This is it. Thank you.
Thank you, Maria. Next, we have Larry. Larry, did you want to run the slides, or did you want me to?
Yeah, I'll share my screen and run the slides.
Off you go. It's a lightning storm here, actually.
Okay, is that working, Adrian?
I'm not so sure.
I don't see anything yet.
Yeah, I haven't seen a shared screen.
I've seen your slides.
Try in the Zoom screen here where all the videos are.
Yeah, I'm doing share slides.
Yeah, there's a little green button to share screen.
Mm-mm.
It gives you a couple of options, whether it's the screen or the browser window.
Share screen, and then I got a bunch of alternatives. So before I get any further into this, Adrian, you better run them.
Okay, let's make sure I've got that. Just getting that on the screen. now. Digital objects and identifiers. Larry.
Okay, thanks. So moving to a world of objects and identifiers, this will be a quick review of some stuff we've been working on for quite a while, in which identifiers are key. So digital object architecture, digital object interface protocol. Next slide. And run all the way through it to the bottom, please, Adrian. So this is the motivation, and we know this, but I feel like I should bring it up anyway. We have a problem. The world is awash in data, your favorite set of V's. Science has gone from articles to data. That's the fourth paradigm. Science is not alone. Commercial industrial data has gone from accounting to tracking all activities like real-time supply chains. All this data should be an improvement, but in fact, data is hard to understand, share, or reuse across the silos in which it starts. Interoperability is hard. When you move data from one domain to another, you lose a lot of context and nuance. One of the problems, especially, is with numbers, because they're not self-explanatory. You can't read 9 and know what it means like you can read a paper. Both human-level description and numbers come with that specific context. How can I find the data I need? Searching for 12 doesn't do you much good. What can I do with the data? Can I trust the data? We know that science now has a reproducibility problem, and we know that scientists spend a lot more time on data than science. And I'd like to emphasize this last point, which is that current data will remain significant long after technology changes fundamentally. That's one of the things I hope people take away if they haven't thought about it yet. Next slide. And again, run all the way through it. So we have to change the problem of too much hard to use, find, and understand data to the advantage of lots of accessible and understandable data that survives over time. So the opportunity is to develop a data-centric infrastructure at a new level of implementation neutral abstraction. So abstraction is a common way that we've solved problems in computing and information management. You know, forever, accounting system is an abstraction over lugging things around, and it's been carried through into programming and information management. Everything, and there's more of this slide, Adrian. Everything in the environment is a digital object. For basic information management tasks, every object can be treated the same, regardless of information content. Every object has a globally unique and actionable identifier, defined and registered type or types. The objects are typed, they're identified, tightly associated metadata. Every object has a queryable set of operations that could be performed on it. That's one of the ways in which this idea begins to differentiate itself from what we do now. You treat every information object the same until you have to differentiate among them to accomplish your purpose. This is not new either. Consider the development of file systems. We don't need to know or understand where those bits are. We get to deal with those bits without caring about them. Internet packet routing. The internet is very efficient at moving packets around. You don't have to design the internet according to what's in the packets. So you get very efficient packet routing. You want to define information objects by function, not by format. You can see object-oriented programming. And again, the point I'm hammering, this will be the second and last time I say it. We need these levels of abstraction because new approaches must enable data to outlive current technology. Anyone who tells you that they know what the computing environment will be like in 50 years doesn't know what they're talking about. Anybody who tells you that scientific measurements that we make today will be of no interest in 50 years is also not correct. So we need to figure out now how to make data survivable with lots of technology changes. Next slide. So this is a generic view. This is a slide I've been using for quite a while, so lots of people probably have seen it. This is sort of the general notion of an object, an identifier-based world. Starting in the right-hand side, you have lots of information storage, information systems, database files, entire systems. And you want to then construct a series of overlays, multiple network services. Many of these exist now, but they're not coordinated in the way we think they need to exist, to abstract all that into a set of persistently identified virtual aggregated digital objects. And that it would include collections. In this world, everything is an object. Those of you who learn Unix at some point in your lives, the analogy there is everything in Unix is a file. In this world, everything is an object and it all lives on a network. I say its name, identifier, and it instantiates itself. And we communicate with these objects with an interface protocol, digital object interface protocol. Next slide, please. So where are we with this? Well, there are relevant specifications. The handle system is an example, though there are other ID specifications. The digital object interface protocol, which is released by the Dana Foundation, which are now the curators of the handle system, assumes identifiers for clients, objects, types, and operations. There's a protocol, and almost essentially every element in the protocol is an identifier. So each request represents a client invoking an operation on a target object, and every one of those is an identifier. There's available software, Cordra.net, which includes a DOIP client, and there's the handle.net software, of course. Implementations, well, we built some of this software, so we're using it. DISCO, the large EU biodiversity project, is employing DOIP and these identifiers in natural sciences identifier registry and cider.org. There's a biodiversity group which is looking at this, iDigBio, Specify, again, DISCO, Indiana University, and CNRI. And then Peking University, I'm very happy about this. They're doing an independent DOIP implementation, so there'll be 2 implementations to that same spec. Next and final slide, please, Adrian. So this is that same picture done vertically instead of horizontally. And the picture you saw 2 slides before was an idealized model of how this would work. This is for the DISCO group and maybe this larger biodiversity confederation is a plan, not implemented, but a plan. And one of the reasons I wanted to show it was that the existing services, which are at the bottom, the existing collections rather, in this case it's museum collections, biodiversity information. Just like the internet didn't make the individual networks that it connects go away, they kept doing what they were doing. You just connected the networks to each other using routers. The idea here is to not ask everyone to change the way they make their data available. Those existing services continue. Those are down pointing arrows. But then new services are built on top where you map into these digital specimen layers. Remember, in this case, we're talking about a specific domain. And you do a lot of linking. This relates to some of the stuff we've heard before. All the kinds of identifiers we're discussing now would be linked together with these. And that in itself would be assembled into a conceptual virtual aggregation layer used by processes, researchers, and other infrastructures. And just one last statement relating back to the first slide. We're inundated by information and data, and we need this extra layer of abstraction, I believe, to begin to really achieve interoperability. That's it. Thank you.
Great. Thank you, Larry. Whistle stop tour. I believe we've got Josh. Are you ready to run the slides?
Would you be all right to steer the slides, actually, Adrian? Because I'm having some problems with the Zoom client at the moment. It keeps crashing every time the presenter changes. So I've had to reconnect with my iPad.
Emotionally, or?
Oh, darling, we were never separate emotionally.
Good. Your hands, Josh. And Adam?
Would you be able to share the slides?
Oh, did I not share? That would have been a really good.
I mean, I'm happy to talk while we all just gaze at you, Adrian. That's...
I look at your slides and people look at me.
I just want people to remember what I'm saying rather than just be thinking about you. Hi, everyone. I'm Josh Brown. I'm speaking on behalf of my colleague, Adam Viles-Moore tonight. He's not very well at the moment, so he's not really able to stay up until the wee hours of the morning to present. So this is a project in the UK. It's being led by GDOC, and we're working towards a PID roadmap for the UK. And for the context of the theme today, it's about joining up PIDs, and it's about joining up the UK PID community with the global network. Next slide, please, Adrian. One of the reasons that we need this UK PID roadmap now is we have been talking about PIDs for a while, but there are a lot of policy and research information initiatives that are coming together that are really telling us that these identifiers are, well, I think to this community, we've already known this for a long time, but it's reached the attention of some quite senior people with money to spend that actually identifiers are really a significant part of the global infrastructure network. Next slide, please, Adrian. And this actually culminated in some of the work that was done through the implementation of a national open access framework in the UK. So Professor Adam Tickell, in his recommendations to the UK government in 2018, recommended that GDOC should lead on selecting and promoting a range of unique identifiers specifically to support open access to UK research. And also that funders should also consider mandating the use of a range of unique identifiers as a condition of grant. So that really kick-started the project we're working on now. Next slide, please, Adrian. Now, what we've done is we took that recommendation and we've done a lot of community research in understanding their needs, beginning to understand some of the pain points in open access, starting with open access article publication, but looking much further back through the research workflows to figure out what we needed to do early. Next slide, please. And we've been working through a number of workflows, starting again, as I said, with gold and green open access to understand which identifiers would really supercharge those workflows and what stages in those workflows we needed to integrate them. So this is just one example of the kind of workflows we've been working through. Next slide, please, Adrian. And the community came up with 5 priority PIDs for open access to UK research. So there are the grant IDs, there are project IDs for which the community sort of went for RAID, person identifiers, so ORCID is the de facto standard for that. Organizations, and RAW has already emerged as the most used organization identifier. So that's the obvious candidate. And DOIs for outputs were our priority because they are the most used, and our aim was coverage and accessibility. Next slide, please, Adrian. So since we kind of reached those priority PIDs, this year, we've been working on much more research and understanding how they should be used. So there have been 2 major pieces of research that we've done. Next slide, please, Adrian. So the first was a series of focus groups, each one looking at one of those priority PIDs. And there's a link to the report on this slide, but some of the key findings were that we need a sustainable and community-driven governance framework for interacting with all of these identifiers, separate from the PID governance itself. We need some interventions to actually kind of demonstrate the value of multiple PIDs and show their interactions and to think globally. We need to be showing leadership and leveraging this project to get attention at the policymaker, the national government, and so on stages. And we need to be really providing a lot of support to all stakeholders and helping them to understand our priority PIDs. Next slide, please, Adrian. So we followed this up by digging into some of these questions around those priority PIDs. And one of the key findings from our survey was that the technical burden and cost of integration are too high for PIDs. That is one of the things that is massively holding adoption back. One of the things that might help to boost the perceived value of PIDs is if metadata was more predictably present and more predictably of good quality. But the benefits that people want from PIDs are better interoperability with internal and external systems, and the ability to reuse data for reporting and analysis, which feeds back to that both adoption and the metadata questions. And interestingly, to kind of help us to narrow our work in even more, the priority PIDs, they want to see those priority PIDs used in 3 priority systems. So that's the funding systems, particularly grant applications and reporting, content platforms, and institutional research information management tools. Next slide, please, Adrian. So taking those priorities, thinking about where we could implement these multi-PID interactions to boost adoption, we've been thinking about how we could actually bring our community together nationally and internationally to actually start to drive that adoption and coverage. So next slide, please, Adrian. So one of our approaches is to develop a kind of national multi-PID, we're calling it a consortium, but it's going to be kind of a range of different kind of consortium models, because we have existing consortia for ORCID or data site membership in the UK. There's the Crossref has its sponsoring organisation membership, and of course RAID and RAW don't have an established membership model. But our idea is consortial support, and it's a way of helping to balance the costs of PID integrations, to contain the costs of supporting adoption, so kind of national PID help desks. And it also means that we have a ready-made community. So for example, in 2022, when RAW launched their next kind of sustainability model, there'll be opportunities there for us to mobilize the whole UK community to get behind that immediately. So what you're seeing on this slide is actually some preliminary work we've been doing around developing a kind of business model for this consortium approach. Next slide, please, Adrian. And overseeing this consortium development, which is at a very exploratory stage, as I think I said, we're establishing a longer-term strategic engagement. So we've had a stakeholder group which has been guiding our work in the project, but we're establishing a long-term research identifier national coordinating committee. And this will be engaging with the UK government and international partners, whether that's governance or the advisory bodies of international PID providers, but it will also liaise within the UK at the operational level with the consortia or community leads for the priority PIDs and community of practice implementers. And they in turn will work with the PID provider technical teams and other international partners as well. So at each level, we have a strategic and operational national and international focus. And the idea there is to make sure that we have this consortium that's driving adoption and coverage. And we have this committee that is actually tying together the strategic priorities of all of these different sections of the community. Next slide, please, Adrian. And so that's where we're going. Please stay in touch if you'd like to find out more about what we're doing. The next step for us is, as I said, to dig into those priority systems and figure out where we could start to develop multi-PID integrations that would actually really demonstrate the value of identifiers and help to increase the quality and coverage of the metadata associated with them and maximize their reuse and adoption across a variety of international open research systems. That's it for me. Thank you.
Great. Thank you, Josh. Now, just checking our final speaker in the lightning tour is Jonathan Clark, one of the co-chairs of this group. He'll be talking to us about PID Federation. Jonathan, did you want to run the slides yourself?
Yeah, could you do the slides for me? Then you don't have to swap.
Sure.
They should be just after Larry's, right at the bottom.
Yeah, I think these ones I know.
Okay, the next one.
Jonathan.
Okay, well, I don't know whether to say good evening, good morning, good afternoon or whatever, but it's 2 o'clock in the morning here in Croatia. So welcome. 5 minutes on the PID Federation. This is actually something that arose out of the Freya project, which some of you might have heard of. The European project looks at all sorts of PID issues. And one of the things they wanted to do was kind of maintain the momentum of the project and the conversations after it. One of the things they established was the PID Forum, which I highly recommend to everyone. But something else that came up was, well, are we actually doing a good job of communicating and getting together as different PID systems around the world? So Josh, who you just heard from, did a piece of research earlier this year. His final report's just been published on Zenodo. There's a link there. And I encourage you to read that. This is kind of my take on his story, but he's on the call, so he can correct me if I get something wrong. Right, Josh? Next slide.
You won't get anything wrong, Jonathan, I trust you.
So really what Josh did was to look for unmet needs in the PID community that a federation or some coming together of PID organizations could address. And the first one, and the one that actually struck me, was that he found amongst the people he talked to that we just weren't inclusive enough as organizations, particularly globally. A lot of us are in Europe and the US, and the conversation seems to center around that. And I think we really do need to work harder on being more globally inclusive. It's tricky. I don't know how to do that, but I do think it's a really good point that Josh raised there. When you're in a conversation and you're on the outside, it's hard to get in the conversation, and we tend to talk amongst ourselves a lot. The other thing I think it should be resonate with a lot of people, we really need to look for more interoperability between systems. And that's one of those things that's easy to say and quite difficult to actually achieve. But things have happened. If you look at the way that your ORCID record updates automatically with your articles from cross-reference data site, that's a great, very useful piece of interoperability. It's small, but I think there's a model there that we perhaps could use to follow. And new ways of communicating. Again, we tend to talk in an echo chamber. I look at the participants list here, and it's great. I recognize many of you. Have seen you at different RDA meetings. Somehow we need to figure out a way of getting more people in and different people, the unusual suspects. And finally, it's really about advocacy, to go really where no PID organization has gone before. Yes, Natasha's seen the Star Trek things here. Really to try and perhaps advocate for PIDs as a whole, rather than, because it's quite difficult when, for instance, as I am the managing agent for DOI, you know, if we start to do advocacy for the DOI, it's very clearly seen as being pro-DOI, whereas I think we'd like something to be broader than that. You know, if the world would just be a better place if there were more persistent identifiers, whoever they get them from. Next slide, please. Now, there was a meeting at Pitapalooza earlier this year, actually the last face-to-face meeting that I did. It was a side meeting from a bunch of people who got together to think about this PID Federation. And the one thing that we all agreed on, there was lots of ideas there, but the one thing that we agreed on was that we didn't need yet another organization with a governance structure, with fees, with just, we were all busy trying to do the best for our own organizations, and we really didn't need somebody messing with us. So I think going forward, this should be the prime directive. Whatever the PID Federation does, and this is my take on Josh's work, it really shouldn't interfere with all the good work that RAID, that Handle, DOI, IGSN, DISCO, whoever it is, are doing. It should enhance it in some way and make it easier for us. Next slide, last slide. And finally, this is really a call for thoughts, opinion, and comments. There's a PID forum discussion live on this. You can contact me or Josh. And really what we ask for is, what can we do? So we know there's a need out there. We know sort of we don't want to tie people up too much, but how could we take this forward? And I know that the Freya group are really interested to hear from all of us. So thank you very much for the 5 minutes. That was, I think, 5 minutes. Back to Adrian.
Thank you, Jonathan. Very nice. Well, more than lightning talks there. And we've seen from the different persistent identifier systems some emerging applications, and then a couple of talks there about the ecosystem of collaborating amongst the initiatives. And that's really where we're moving the discussion for the rest of the session. We've got another about 20 minutes, let's say, for discussion there. So actually, coming off Jonathan's presentation there, are there any thoughts on some of the questions that Jonathan was asking about? Is that, you know, how then acknowledging that we wouldn't want to interfere with different PID initiatives, what kind of collaboration or communication or coordination do you think might be beneficial? So I'm happy to push this open now to the whole floor. I'll start with those people who presented, and maybe specifically the first 4 or 5 that were talking about specific PID systems. What do you see as enablers or advantages of greater coordination between persistent identifier systems?
I'm not sure if I'm the right person to speak to about this, but you know, I actually do see a lot of coordination already within the PID community. I mean, ORCID's been really good about accepting other kinds of works, other kinds of PID systems into itself. And I think that's true for, you know, everybody that I've ever interacted with in this community. So I think there's a lot of that, but what that leads to is this kind of many-to-many problem. There isn't a federation currently, that there isn't like one place where you can plug in your identifiers. Although maybe California Digital Library has, I would say, probably the closest thing to it. Perhaps not quite the, you know, one-to-many kind of a PID system, but is that a goal of this federation? Creating a one-to-many instead of a many-to-many kind of an integration?
Well, I think it was definitely a stated aim to increase interoperability, to enable interoperability. See, Larry's got his hand up. Larry, did you want to make a comment?
Yeah, interoperability is a very big word, or you know, there's lots of ways to define that, and I think pursuing the question that we were just discussing would be useful to try some use cases out. What exactly do you want to be interoperable, and how do you want it to go forward? What's a current non-interoperability problem, and then try and work your way out from there.
So was that?
So that's something that a PID federation could do. You could see it as a sort of a working group, a way to bring these things together, pose the user stories, the case studies, and see how they would be solved, and then try and go from there, rather than design a system ahead of time.
Yes, absolutely. Interoperability, just trying to get n number of things to potentially interact with n number of things is kind of an architectural nightmare. But having some pluggable systems, I think, was what Anita was talking about, was, you know, we do have use cases where you do want one PID system to interact with another one. And I think that's where Anita was saying that you're kind of doing that over and over again. So yes, a forum that would allow us to recognize those repeatable business processes and technical workflows, and to use Larry's abstraction word, to abstract those up to something that can be reused between systems.
I mean, I find actually the thing that holds back interoperability is often not the technical side, but it's the human side. Just knowing things about each other can often help. one of the ideas I had back in PIDs I suggested was that we sort of take a topic and maybe do a round. So the DOI Foundation, for instance, could host a meeting, especially now virtually. We could host a meeting with whoever wants to turn up from the other systems and talk about persistence, for instance. What are we all doing to maintain and guarantee the persistence? What about the persistence of the object that we point to? I mean, lots of issues, but it's a rich thing that if we're thinking about it, I guarantee others are thinking about it. If we talk a little bit about, at least have some cross fertilization of each other, then I think we naturally come together to good solutions. And the same will be true, say, of something that we've also been talking about, alternate IDs. So one of the deployments of DOI is in the movie industry, and they use it to map disparate identifiers of a movie as it passes through the supply chain, and they use the ider identifier to map to all those alternate IDs. There must be, I mean, objects out there have multiple identifiers. There surely must be something we can do there to try and bring them together and at least acknowledge each other. You know, this identifier also known as this one, this DOI also known as an ARC or whatever it is. So I think there are at least a couple of things. And my sort of low tech first solution was, let's just organize the sessions with each other. And yes, I'm happy to start.
Yeah, absolutely. Through communication, you know, increased communication, at least you're not replicating things that you just didn't know about. Anita?
So actually one of the things that, you know, my group has been struggling with is software tools. And we're actually undergoing a kind of a massive mapping effort right now between a couple of the different identifier systems for software tools. They're all extrinsic repositories. But we'd like to be able to, you know, essentially allow anyone to cross map what they like. But it would be something that would be very interesting, I think, for many groups, because one of the things that, I mean, as an owner of some, you know, some PIDs, in addition to you know, registries, I actually have to, or somebody registers my stuff into their systems and then I have to go fix it. And that kind of is, I think we've all probably done that multiple times. And, you know, it's fine if you want to say something about my systems and you want to say, this is how you should or should not identify my thing. That's okay. That's within your extrinsic repository or what have you. But it would be nice to have some coordination amongst these things so that, you know, if I register my tool in one place, that, you know, that data packet kind of flows around to where it needs to flow if somebody wants to pick it up, and also identify it in their systems. And I mean, I think maybe a way of thinking about this for me, and maybe Dan Katz can tell me I'm all wrong, but a way, you know, I kind of think of this is, you know, in archive, you might have somebody who would pick up an object and say, hey, I like this, I'm going to make a virtual, you know, I'm going to add that to my virtual journal. And those are the kinds of things, because, you know, there are these objects out there and a lot of people do research on them. So it would be nice if there was some way of kind of identifying and moving that information around. I know it's pie in the sky, but
this is where Larry tells us all again about digital object architectures, right?
There's a comment by Carsten there in the chat about potentially the role of Chris and Chris systems. Did you want to elaborate on that, Carsten?
Could do that, but it's more just an idea or a thought that I think all this holds great potential, but at the end of the day, if a lot of users sit in Chris systems that really doesn't support this, and Chris sits very tight at the universities, at least from a Danish point of view. So thinking about the role of the Chris systems and how we can roll out these PIDs easier, perhaps to Chris I think is worth a consideration.
Yes, it is. And I think that's a thing we saw in a number of these. Well, it's a message that I took from Maria's presentation about the data management plans, that a similar kind of institutional system that's being used, and then it's helping then to link in the different persistent identifiers. So yeah, having the right tools there. So I think that's a theme of persistent identifier adoption. How that might play in the federation sort of concept that Jonathan's put on the table, it would be very good. If we're talking about a PID federation, we should not forget that it's not just the PID service providers like ORCID and DOI that need to be in this communication and federation. It's the big enterprise information systems that are used at universities, as well as the lab systems that are used by researchers, that we need to also bring into this conversation, into that federation, so that the adoption pathway is very clear.
I'd hope that the work we're doing in the UK project, because as I said, one of the 3 priority areas is institutional research information management systems, or CRISs and others in that family. So looking at the workflows where there are these kind of maximal opportunities to demonstrate the benefits of PIDs in those systems might help to motivate some of the system providers to actually help us and come on board and do some of that development work.
Now, got some comments in the chat there. I'm not sure whether people want to bring those out into the conversation here. Rob Hooft has talked about format registries and object types. Is that in response to Dan or in response to the conversation that was happening?
That's actually in response to the whole session. So I'm definitely not an expert on PIDs, but I do see the contrast between what I'm seeing in DISCO and what Larry talked about, where you say, okay, we want to make a data record that points to everything that is known about this object. We give it an identifier, but we also want to refer to identifiers everywhere else. At the moment, the way this needs to be done is that such a record has, for instance, for a butterfly, it has the link to the sequence in the sequence database. It needs to know that the identifier here is a sequence identifier. It needs to know for the author that it's an ORCID, it's an author identifier. In an ideal world, you just say, okay, everything we know about this object is, and then a range of PIDs, and it doesn't matter. The semantics of the PIDs actually is completely clear, and the types, the object types, come from the metadata of the PIDs. Now that's very far away, but I see that Larry with the digital object architecture is going in that direction, whereas what I noticed from this session is there are new groups of objects that need to be getting identifiers. So let's build an identifier system for them, which needs to be then by every system that needs to recognize them, needs to recognize, okay, this is a PID, this is how to resolve them for each of these different types. So we build ourselves an interoperability hell.
I think that's a really important point, and actually there's a really valuable component role here that the PID Federation or a potential PID Federation could play, because one of the things that I heard time and again in the research for that was that people really valued those grassroots, the bottom-up approach to building PIDs, because it's close to their community, it's responsive to their needs, it reflects their specific situation. But we do need to make sure that there is a framework and there is guidance and there is support for people building these new PID systems, so they're not building themselves into a blind alley when they set something up, so that the interoperability is there, designed in from the start. So I think there's a really important role for this community federation of people who have made those mistakes in the past to share that. So it's like almost a shared knowledge vehicle, an organizational memory, if you like, for the PID community, I think is one major role for this.
PID mentoring.
Go ahead, Larry.
PID mentoring.
Well, and the other thing that we've been looking at is, could we make it easy at some point in the future to migrate from one PID system into another? Could they come together? If the architecture is right, then that's not impossible. We've looked particularly at handle implementations because DOI is a implementation of handle. So to move from a handle implementation into a DOI might not be too difficult. And the second thing on that is we've also looked at whether we could, this is a little bit virtually DOI something. So could we take any identifier and make it behave like a DOI and follow the policies and the guarantees that the DOIs need to comply to? But could we create some kind of virtualization of it so it's not system based, and so that people could come and say, look, here's our identifier, here's our system. If it fulfills a set of criteria about persistence and about stability and sustainability, then we might be able to DOIfy them and bring them in and make them interoperable. It's a bit of a dream, but it's something that we're thinking about.
So this is also an interesting point. It is very nice about DOI and handles that they resolve each other's stuff. And there are some other PID systems that do such services as well. In my dream world, all the resolvers would 301 to each other. So, okay, you don't know what it is, but I know that this is the resolver for this identifier. So I'm pointing you to the resolver for this specific type. And that way, ORCID could be saying, okay, this is not an ORCID, this is a DOI. I 301 you to dx.doi.org and the other way around.
Well, we can even, Larry will tell you, we've worked on a URM resolver that you could plug it into the handle system and it would resolve. So we could do things like that. We could provide resolving services to other PIDs. Well, we technically have to jump through some loops, but we've done a pilot on it, right, Larry?
Yes, it works.
That really helps.
How does that play with like the identifiers.org or the entity resolver kind of world? Is that what you're talking about or that you've done, or is this something separate from that?
This is basically feeding a URN to the web-based handle or DOI resolver and going from there. It requires understanding, of course, in the URN world, where to go to resolve it, and that's the trick in that world. If there are n URN systems, then you have to know where the information is recorded.
Dan Katz has his hand up in the participant list. Did you want to chime in?
Yeah, thank you. Yeah, so I guess I was just going to say that I think this idea that you guys are talking about now is a great goal, but we're so far away from that today that I feel like there's a bunch of practical things that also would be good to think about. And so just as I was putting in chat, today, if you look at a random DOI, there's no way of knowing what it is. Right? You can't tell if it's an article or a data set or software. So there's, and that's just one kind of identifier. So I don't know, I feel like there's a bunch of problems that it would be good to solve today, as well as working on these things that are going to a better system tomorrow, but not just to jump to the system tomorrow that kind of hide some of the problems we have today. The other one thing that I was going to say was just from the other comment that I had made is that at least I think there's this question of dynamicity in some sense that really is important, and that kind of is what Moran was saying with the intrinsic identifiers for software, that there are some things that are changing so frequently that the identifier systems that we have now are kind of make assumptions that are not clear if they're completely right or not. Right? Having an identifier for a person is pretty clear. That makes sense. Having an identifier for an organization makes sense. For a paper makes sense. For a data set mostly makes sense as long as it's not too dynamic. But for software, I'm not really sure that it makes sense the way we have it at this point.
Now, I'm just keeping an eye on time, which is slipping away from us at 25 past the hour. We did have a couple of questions there around what next steps might be in that kind of a federation. I think there's a number of things we didn't even talk about, increased communication, which was another thing of Jonathan's. We've talked around a number of the interoperability aspects that might be improved. What kind of steps does this group think might, given that we, Star Wars, we know where we want to be, but what the practical next steps might be around creating an organization that enables this kind of stuff, or even just starting to increase communication, increase sharing of information amongst the different participants. Does anyone, that was just one of the questions, what some next pragmatic steps might be. Any thoughts on that?
So I might do. I think that the Freya project is, I was waiting for someone to say something, but never mind. I think that the Freya project, or at least I know because they've been in touch, are thinking about how to propose it. I would guess that there's a session at PIDapalooza coming up to talk about this further, but I do think there's and they've asked me to help with some of that. But that's really what I wanted to do here, was poll ideas and thoughts. And I agree with Natasha on the chat. I think there's a number of issues that come up today that clearly are worth talking about. And maybe it's just a case of just launching out and trying something. I'm not sure we need it to be too organized. And there are some advantages about being virtual. It's nice to see each other face to face, but hey, this works too. So maybe we just have a theme-based meeting and we just go for it. But I'll talk to the Freya people and see if I don't want to tread on people's toes. But I'm happy to bite the bullet and host a first session online. Anyway, go to PIDapalooza. That's the message from Anita.
Good. Well, funny you should say that. Before we, so I think we should take at least some of the ideas out of this conversation, because there were some very good ones around operability and communication, and capture them and pass them along to the next meeting so that we're not starting again from scratch. And I've got some really nice notes here on the kinds of people, the kinds of interoperability challenges, etc. However, if you don't know, so this is, I don't know who everyone on the call today, if you don't know PIDapalooza, I would recommend that you register for this event. It's a very good persistent identifier community event. It would be remiss of me to also not encourage you to join the group, the persistent identifier interest group. So if you've attended this session and got, no matter what, if you've attended this session, go to this page here. It's the Research Data Alliance PID interest group page. Click on this little thing here, join the group. That means every time there's new announcements or shared information, you'll get it through this group as well. I should flag just in the minute we've got left, Laurie Huck, who was the director of ORCID, was also the co-chair of this group, and she's moved on from that. She's moved on from this role here. So Jonathan and I will be sending an email out to this group's, to that group list. Another reason to join there, just to kind of poll your ideas on another chair or two. I think you can have up to 4 in an RDA group. So that's just flagging a little bit of homework. Thank you very much, everyone. It's been an excellent, I feel that I've caught up on a lot of great things. We've got a nice piece of work moving into the future around coordination and coherence, which is always great. Thanks very much for all your participation. And
thank you, Adrian.
See you at the next meeting.
Yeah, thanks, Adrian and Natasha.